Hi everyone. This is another Coulombs Law example. This is a triangle, and let's see how this goes. So we're going to find our force on Q1. So let's see how it's arranged here. Imagine 3 points on the corners of a triangle. We have -9 nanocoulombs at the origin. We have 2 nanocoulombs at x equals 2, and 3 at Q3, 7 nanocoulombs at y equals 3. So what I'm going to do is I'm going to draw a straight line here because I want to like diagram this out here. Okay, we have Q1 at the origin, so here we go. Here's Q1, and that is -9. I'm going to go ahead and put this into nanocoulombs right away. So Q2 is at x equals 2 meters. So I'm going to call this Q2, which is a -8 nanocoulombs over here, and the distance right here is 2 meters. And up here we're at y equals 3, so about here, a little further away, 3 meters away. And this one's a +7, like that. Okay, so the question is, what's going on here? Okay, so what's the force of this system right here? All right, let's figure this out. So as always, my first step is to find the direction of each of the forces. And the way we're going to do that is we're going to draw the direction by considering if they're attractive, basically, and repulsive. That's what I'm doing here. I'm asking, is this attractive or repulsive? And then once I figure that out, I draw that in. So let's see. And this is Q3, right? Yeah. Okay, let's look at Q3 first. You can do it any way you want. Why not? We'll do Q3. All right, so Q3, we have a negative charge and a positive charge, which means this one's going to be drawn toward that charge. So this is going to be forward. So the force of 3 onto 1 is going to be up, just like that. And again, that's because this is negative and this is positive, so it's attracted. Now let's ignore that one and look at Q2. Q2 is negative. Q1's negative. Negative, negative. So what do you think is going to happen if they're negative and negative? That's right, they will repel. So this one will be pushed away. So this is the force of 2 onto 1. And there we have it. The question is, how big is this force? How big is this force? And what's the answer? So just looking at that, I can see that we're going to the left and up. So there's going to be some sort of force. I don't know how strong. Since this one's closer, it probably has a bigger influence. So I'm going to assume that this is going to do something like that. Just like that. I don't know actually what's going to happen until I solve it, but since this is closer, it's going to have a bigger push. So I think it's going to go more left than up. And that's the way I have it drawn right here. Okay. So next up is I find the strength. So, and I don't use signs. I'm going to consider direction later. So don't put negatives and etc. like that. So when I do that, I'm going to find them. So I'm going to find force of 2, 1 first. Okay, Q2, Q1 are squared, and the distance between the two. This is 8.99 times 10 to the 9th newtons meters squared over Coulomb squared times Q2. So that one is the negative. Well, I'm going to ignore the negative, remember, and just put the 8 there. I just want to know how strong it is. And same thing, I'm going to ignore that sign, so I'm just going to make it as positive here. Now the distance between the two of them is 2 meters, so that's how far apart they are, just like that. Okay, I'm going to set up the next one and I'll just punch out both of these on my calculator. Okay, so K is the 8.99 times 10 to the 9th. Just like that. Let's see. Q3 is that one up there. Good. Q1 is that one, ignoring the sign. And then I ask myself how far apart they are. This problem's nice, it gave us 3 meters. And then we gotta square that number. Alright, let me punch these into my calculator. So let's do that. 8.99 e to the 9th times 8 e to the negative 9 times 9 e to the negative 9 divided by 2 squared. This one right here is the 1.62 times 10 to the negative 7th newtons. Okay, and then I'm going to do the same thing here. 9 e to the 9th, 7 e to the negative 9 times 9 e to the negative 9 divided by 3 squared. And I get 6.29 times 10 negative 8 newtons. Now for both of these, in terms of rounding, I usually just round off to the second digit, if you notice, after the decimal place. I'm not too particular, but I don't want all the numbers on your calculator, so just round to a couple decimal places, just to get a sense of the value. Usually 2 is fine. Okay, what did we find? We've just basically found how strong this one's being pushed this way and that way. So step 3, I gotta find their x and y, so analyze their x and y components. So I like this problem because there's no angles here, and I have purely up and down, right and left kind of thing, so this makes it a lot easier. So if you look at 2, this is completely to the left. Since there's no angle or it's going up and down, this is an x component completely in this direction, and since it's going to the left, it's negative. So this is an x component that's negative, which makes the y component a nice easy 0. Oof, I love when that happens. So much easier than going through the trig. And it actually happens here too. See how this is pointing directly up? There's no angle here. There's no right or left. There's no down. So this is a y component because it's pointing in the y direction. It's also up, which makes this positive. So that means that the force through 1x is going to be a nice easy negative. Nice easy 0, sorry. Cool. I got the x and y's just by analyzing this. Now you can go ahead and do sines and cosines. You actually will get these answers, but this is the easier way to do it. Now I'm going to add up the x and y's to get the x to get totals. So let's go ahead and do that. My x and my y. So my force 2, 1, my force 3, 1. And get my total. Let's add those up. My x 2, 1 is negative 1.62 times 10 to negative 7 newtons. This one's going to be 0. This one is going to be 0. And this one is going to be the 6.29 to negative 8. Which makes adding them nice and easy because we're just adding 0 to each of these. So woo on that. And then my last step, okay, I can put my last step down here, step 5 here, is we make a triangle with our x total, my y total, find the hypotenuse, which is my force, my net force, and my angle. So there we go. Notice that this is negative, so my arrows actually go this way because it's negative. Oops. You don't need to put the negative here. if you have the arrow, but I won't like mark you wrong if you put a negative there. It's you're right, going to the left, and then we're going up here. So that's why that one is pointing up. And this is what we're solving for. Okay, right here. Okay, let's find the net force. We're going to do that by using the Pythagorean theorem, so we could do that in one step with the 6.29 times 10 to the negative 8 newtons squared plus. Now, I'm ignoring the negative because it's just gonna, with the squared right here, it just goes away. You can throw it in here, it's technically right, but I'm not. I'll just leave it there. Why not? It works out. So let's go ahead and finish solving this. So this is going to be that squared plus this number. Okay, plus, there we go, 0.62 e to the negative 9th squared. And we're going to square root that. Okay, so we get 6.29, I guess 6.3. Let's go ahead and run those 6.3. Oh, times 10 to the negative 8th newtons. So that's the value of this force here. Now we need to know what this angle is right here. So let's go ahead and find the angle. I'm going to do that with inverse tan of the y. So the 6.29 times 10 to the negative 8th newtons divided by the x. So I got to do the inverse tan. It's very important to also, let's see. So inverse tan of 6.29 e to the negative 8 divided by 1.62 e to the negative 9. Right? That's right. That looks good. Uh-oh. Ah, darn. I was wondering why this number looked a little weird. This should be to the 7th. Let me quickly fix that. I was looking at that. It looks funny. Alright. Alright, give me 1 sec. Probably caught it before I did. That's the 7th. Alright, let me fix that. 6.29 e to the negative 8 squared plus 1.62 e to the negative 7 squared. Okay, that looks a lot better. There's my number. 1.73 to the negative 7th. Whew. Okay, that's the right answer. Ooh, that answer looked funny. Okay, good. Alright, and then 1.62 times 10 to the negative 7 newtons. Alright, let's finish this up. We're almost there. Hang in there. E to the negative 7th. Inverse tan of that. So the angle that I get here is 21.21 degrees. So that's what's right here. So what we found is that it is actually, I did draw pretty good actually. I guessed it very well. So that's the net force. It's 21.21 degrees from here. So notice that changes my answer. So it would read 1.73 times 10 to the negative 7 newtons at 21.21 degrees above negative x-axis. So notice how that changes because I'm measuring the angle from here. You can say the angle from here, which is you add, basically subtract this from 180 and get this angle. That would be fine too. But notice the way that we write this to signify where we're taking our angle from. Because notice our triangle, because we're going to the left, looks like this. And that's what we're measuring here. So that's how you solve a triangle type problem.